Hi, this is Jaydeep Sai, and the topic which I have selected for this TikTok video is a machine learning based framework for optimizing the operation of future networks. So let's discuss the abstract of the title. The abstract is 5G and beyond are not only sophisticated and difficult to manage, but must also satisfy a wide range of stringent performance requirements and adapt quickly to changes in traffic and network state. Advances in machine learning and parallel computing underpin a new powerful tools that have the potential to tackle these complex challenges. In this article, we developed a general machine learning based framework that leverages artificial intelligence to forecast future traffic demands and characterize traffic features. This makes it possible to exploit such traffic insights to improve performance of critical network control mechanisms such as load balancing, routing, and scheduling. So the 5G and beyond are not only sophisticated and difficult to manage, but must also satisfy a wide range of stringent performance requirements, adapt quickly to changes in traffic and network state. Advances in machine learning and parallel computing underpin new powerful tools that have a potential to tackle these complex challenges. So 5G and beyond are not only sophisticated and difficult to manage. So these 5G technologies are not only advanced technologies, but they are difficult to manage, but must also satisfy a wide range of stringent performance requirements. So even though these are the highly technological 5G networks, and but these are difficult to manage, and this has to satisfy the stringent performance requirements such as speed and also quickly to change it in traffic and network state. So this have to manage the traffic where the many of the users use the network, same network, 5G network. At this point of time, the 5G network should manage the high amount of traffic and should also make sure that the requirements are satisfied. So in this article, we develop a general machine learning based framework that leverages artificial intelligence to forecast future traffic demands and characterize traffic filters. This makes it possible to exploit such traffic insights to improve the performance of critical network control mechanisms such as load balancing, routing, and scheduling. This is about the abstract of the title. In contrast to prior work, so the design problem-specific machine learning algorithms, a generic approach can be applied to different network functions, allowing reuse of existing control mechanisms with minimal modification. We explain how our framework can orchestrate ML to improve two different network mechanisms. Further, we undertake validation by implementing one of these model backhaul routing using data collected by a major European operator and demonstrating a 3 reduction of packet delay compared to traditional approaches. So let's discuss the introduction of the title. Recent advances in machine learning enable optimization at levels of complexity that were previously unaffordable. This has led to dramatic performance improvements, forecasting for fostering the use of ML algorithms like neural networks across wide range of fields. Harnessing ML to enhance the performance of wireless network started with 5G and will be essential to promote zero touch configuration and management, thereby enabling self configuration and self optimization envisioned for 6G networks. So, the recent advancements in the machine learning enable optimization at the level of complexity that were previously unaffordable. So, in the 5G networking, where we are using the 5G network, there are some of the limitations and some of the complexities that were not so efficient in handling those complexities. Now, the recent advancement in the machine learning has enabled the optimization at the levels of the complexity. This has led to the dramatic performance improvements. So, this has led to the dramatic performance improvements. The performance has been improved and fostering the use of ML algorithms like neural network across wide range of fields. Harnessing ML to enhance the performance of wireless networks started with 5G and will essential to promote zero-touch configuration and management, thereby enabling self-configuration and self-optimization envisioned for 6G networks. So the 5G networks was for performance we have to manually configure the configurations, but after the implementation of the machine learning, we are visioning for the 6G network to be automatic self configuration, self optimization. So at the high amount of the traffic or for the when the performance issue may occur, at that time by using the machine learning algorithm, we are making the model to make the self configuration, self optimization steps are being implemented automatically by using the machine learning algorithms. So at that reason, by the that we are optimizing the 6G network for the future. ML-based 5G network optimization. We propose the ML-based framework for network optimization and explain how to incorporate it with 5G network. ML-based framework. Figure 1 illustrates the building block of our framework, which encompasses the ML orchestrator modules to measure mobile network traffic, ML algorithms that process this data, models performing specific network optimization based on the output of the ML algorithm. So this is the ML orchestrator, and measure points are there. The measure points are base station, UEs, edge data centers, etc. And the data is sent from these measurement points, and the extraction of input parameters, packet length, inter-arrival times, flow duration, etc. These are the data that are sent for the extraction of the input parameter, and for the extraction of the input parameters is sent to the ML algorithms. So the ML algorithms are traffic classification and traffic forecasting. These are the ML algorithms that are using the processing and making the decision models, scheduling, routing, orchestration, and load balancing. These are the performance that are made. And for the errors, there is a traffic parameters. We are handling the errors in the traffic forecasting. 5G architecture integration. The design of our framework adheres to the UTUT guidelines. Although it is tailored specifically for beyond 5G networks, the solution is backward compatible with 4G network, expects with limited range of network mechanisms that can be optimized. Our framework can instantiate measurement modules in the core, backhaul, fronthaul, and radio access network RAN, while exploiting standard interfaces to extract measurements from the network equipments. This is about the 5G architecture integration. Load balancing. Advanced knowledge of behavior and characteristics of different flows, such as the average peak rate and level of burstness, allows intelligent assignment of different flows to base stations and scale in and out VNF resources. Load balancing may be based on average load or the statistical behavior of the different flows and the probability that they congest the corresponding base station. More importantly, prediction-based load balancing can occur proactively rather than reactively. That is, when some base stations have already been congested. This is about the load balancing. The load balancing is the state where the lot of the traffic can be seen, and this traffic can be diverted, and they have to split it to balance the load. So this is about the load balancing and orchestration and use case implementation. We demonstrate how proposed ML-based optimization framework can be instantiated to orchestrate simultaneous ML pipelines for learning-driven routing and VNF scaling. Further, we assess the benefits of ML in the former use case. Let us consider part of mobile core network, a cluster of ENBs deployed in the city of Milan. We envision a set of routing nodes that connect the ENBs to core network via diverse backhaul links. The traffic measurements were collected by Telecom Italia between November and December 2013. This is the orchestration and use case of implementation. Now let's discuss about the orchestration. In a 5G core network with control user plane separation, the user plane function UPF takes care of data path while AMF and SMF cover the control path. AMF performs functions related to our user authentication and authorization and handles mobility management. SMF is in charge of all session management functions, allocates IP addresses, and selects the UPF. Our ML framework will simultaneously orchestrate the scaling of AMF and routing. The orchestrator instructs one ML pipeline to gather control traffic to determine the number of accepted UEs and the time they need to attach the network. This is about the orchestration. So now we have come to the conclusion of our title. So in this conclusion, let's discuss about the conclusion. In this article, we present an ML-based framework to optimize the operation of beyond 5G networks. Unlike current approaches that embed ML directly within the network control systems, our framework does not require designing use case specific ML algorithms and changing existing network algorithms. Our framework instantiates ML pipelines to characterize traffic features and predict future traffic demands. The predictions are subsequently fed into existing network control managed mechanisms. Our approach brings together and harmonizes concepts from ITUT, 3GPP, and other specification in single comprehensive framework. So in this article, we are presenting the ML-based framework that optimization of the operation beyond 5G network. So the beyond 5G network, we are focusing on the 6G network where we are using the ML, the machine learning algorithms for optimizing self-optimization and for the self-traffic configurations. So we are using this ML-based approaches for our 6G networks, and a framework does not require designing use case specific ML algorithms and changing existing network algorithms. Our framework instantiates ML pipelines to characterize traffic features and predict future traffic demands. So this can manage the future traffic demand and can also predict the future traffic demand. These predictions are subsequently fed into existing network control mechanisms. Our approach brings together the harmonious concepts from ITUT, 3GPP, and other specifications in single comprehensive framework. This is about the conclusion of the topic. I thank the faculty and college for providing me this opportunity to speak on the topic. Thank you. Jai Hind.